We will be looking at geometric sequences in depth in this video. In the last video we looked at arithmetic sequences in depth. Recall that a geometric sequence is one in which there is a common ratio, so a multiplier, between two adjacent terms. And that multiplier, that common ratio, you can get by taking one term and dividing it by the one before it. The formula rule for the nth term of a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. A sub 1 is the initial term, the first term, and r is that common ratio, that multiplier. And then of course n is your index number, or also called your term number. So example 1, for the geometric sequence 2, 6, 18, 54, find the common ratio r and the general formula for the generation of the nth term. So we can take any of these and divide it by the one before it. I'm going to take this one and divide it by the one before it. So that would be 6 divided by 2. R is equal to that. So R is 3. So a sub 1 is the first term 2. We found R to be 3. So we simply plug it into that formula, and to generate the nth term we would use 2 times 3 to the n minus 1. And that's it for example 1. Alright, example 2, find the 16th term of this geometric sequence. So again, we're using our formula here. So a sub 1 is equal to negative 2, and our r value, we can take any term. So I'll take negative 8, divide it by the one before it to get the r value. So r is negative 2. So that means our formula is negative 2 times negative 2 to the n minus 1. And that is our a sub n value. So if we want a sub 16, we simply plug in a 16 right there and work it out. So negative 2 to the 16 minus 1, which equals negative 2 times negative 2 raised to the 15th power. So we can put that in our calculator from there and type it like we see it here, raised to the 15th. And we get 65,536. So 65,536 is the 16th term of this geometric sequence. Okay, example 3. A particular geometric sequence has negative 14 as its fourth term, so that would be a sub 4 equals negative 14. And negative 16 as its sixth term, so a sub 6, negative 16. What is the 23rd term? So a sub 23 is what we are trying to find. So in our formula we need the r value and we need the a sub 1 value. So we're going to have to find this r value first. We need to find that common ratio. So just like when we worked with arithmetic sequences in this case, we're going to need to make an adjustment. So the a sub 4 term becomes our adjusted first term. So I just subtract 3 from that index value of 4 to get the 1 here. So I need to subtract 3 from the others. So a sub 3, this adjusted value becomes a sub 3. And the adjusted here would be a sub 20. So with that information we can find r. So negative 16 is equal to a sub 1, negative 14 times r to the n minus 1. Well, we used 3 for the index value, so simplify that a little bit. Negative 16 equals negative 14 times r to the second power. So we'll divide both sides by negative 14, solving for r here. And we get positive 8 over 7 equals r squared. So then square root both sides, and we get r is equal to plus or minus square root of 8 over 7. So there is our r value. Now we can take that information, plug it into the formula again to find the adjusted 20th value. So our adjusted 20th value, which is actually the 23rd from the original, is equal to a sub 1, our adjusted a sub 1, negative 14, times the plus or minus square root of 8/7, all raised to the n minus 1 power. We're using 20 as our index, so that would be to the 19th power. So once we do that, we'll need to use our calculator here. We'll get actually plus or minus value there. So let's put that in. So we get negative 14 times the square root of 8 over 7. Close that parentheses, raise it to the 19th power. And we get negative 49.7796. And then if we copy this down, do the same thing, just insert a negative here, all that's going to change is the sign. So here, second, insert a negative, run it again, and you see we just get the opposite sign. So it's plus or minus 49.78. We'll round to two places. Plus or minus 49.78. So our adjusted value there, so this was our original a sub 23, is equal to plus or minus 49.78. All right, again, for clarification, we were finding the actual 23rd term of based on the given information, but we did adjust it to a sub 20. So at the end, you need to make sure and go back to your original, because we are actually finding the 23rd term, not the actual 20th term. We have to make that adjustment in the beginning, and then at the very end make the adjustment back to get our answer. The 23rd term would be plus or minus 49.78. Okay, this next section, the terms between two given terms of a geometric sequence are known as the geometric means. So a shortcut for finding the single, this is important, just the one geometric mean between two given terms would be using this formula here. So the 13th term of a geometric sequence is negative 204. So a sub 13 is negative 204. And the 15th term, a sub 15, is negative 46. What does the geometric mean, a sub 14? So we're finding the one in between. So all we're going to do is plug that into this formula. So that would be plus or minus the square root of this whole quantity. So that would be negative 46 times negative 204. And we'll just put that in our calculator here. Second square root, negative 46 times negative 204. And we get plus or minus 96.87. And that would be our 14th term. A sub 14 would equal plus or minus 96.87. Example 5, a particular geometric sequence has a sub 1 equals negative 1 and a sub 5 equals negative 81. What are the three geometric means between? So a sub 1, negative 1, a sub 2 equals, we don't know, we want to find it. A sub 3, we don't know, we want to find it. A sub 4, we want to find, and we're given a sub 5, negative 81. So the first thing that we need to do is find this common ratio, and no adjustment is needed because they actually give us the first index value, so we don't have to make an adjustment like we were doing in those earlier examples. So we just plug in the given information to the formula. So I'm going to use the last term they gave me, negative 81, as my a sub n value here. So negative 81 equals, my a sub 1 is negative 1 times the r value, which I don't know yet, raised to the n minus 1 power, so that would be 5 minus 1 because I'm using the fifth term. So simplify a little there, and we get r to the fourth power. So divide by negative 1, and we get 81 is equal to r to the fourth. So we take the fourth root of both sides, and the fourth root of 81 happens to be 3. So plus or minus is, whenever you take an even root in your algebraic process, you have to include the plus or minus. So our common ratio is both positive and negative 3. So we're going to have multiple sets of answers here. So I'm going to make one list with r equal to 3, and I'm going to make another list with r equal to negative 3. So all we're going to do, now that we have our common ratio, is we're going to multiply these by each one of those, 3 and negative 3. So 3 times negative 1 gives us a a negative 3. Then that times 3 gives us negative 9. That times 3 gives us negative 27. Negative 27 times 3 would give us the negative 81. So those are with the r value being positive 3. Now we have to do the same thing with r being negative 3. So negative 3 times negative 1, positive 3, times negative 3, negative 9, times negative 3, positive 27, times negative 3 would give us negative 81. So we are alternating positive, negative, positive, negative, positive with that one. But the original, with r value of 3, they're all negative. So we have two sets of answers here in each case because we have a plus or minus value for our common ratio. So that is it for this lesson, and that is it for this video.